Hello everyone and welcome to this video on the Python programming language and machine learning. So in this video we're going to analyze the Titanic data set, and for those of you who don't know, the RMS Titanic was known as the unsinkable ship and was the largest, most luxurious passenger ship of its time. Sadly, the British ocean liner sank on April 15th, 1912, killing over 1,500 people while just 705 individuals survived. And so we're going to analyze the Titanic data set and try to write a program that predicts if a passenger will survive on the Titanic. And then we're going to make a prediction to see if I would have survived on the Titanic. All right, so let's go ahead and get started. But before we do, I need to let you know that I'm on Google's website called colab.research.google.com because it makes it really easy to get started writing your Python program. So you don't have to install the Python programming language onto your computer. You can just go to this website and then log in using your Google account and start writing your Python code right away. So let's go ahead and start writing our program. Just go over here to File and then go down to New Python 3 Notebook and click it there. And then a new tab opens up for us and a new cell where we can start writing our code. So in comments, I like to put a description of what my program does. This way I can look back at my program and I know immediately what it does, and other people who are reading my code can do the same. Okay? All right, so let's go ahead and write this description. And again, this program predicts if a passenger will survive on the Titanic. Okay? And then I'm going to create a new cell by clicking this code button. And I'm going to import the packages or libraries which make it easier to write my program. So here in comments, I'm going to put import libraries. And the libraries that I'm going to use are NumPy, Pandas, Seaborn, and matplotlib.pyplot. So let's import NumPy as NP, and then we're going to import Pandas as PD, and I'm going to import Seaborn as SNS, and then I'm going to import matplotlib.pyplot as PLT. Okay, and then I'm going to run this by clicking this button here to the left, and hopefully there are no errors. All right, so everything looks good. We didn't get any error messages. So let's create a new cell, and now let's load the data. So we're going to load the Titanic data set. So I'm going to create a variable called Titanic and set it equal to SNS, which is the package that contains our data set. And then I want to use the method load underscore data set. And I need to tell it what data set to load. And we want to load the Titanic data set. And once we have it loaded, I want to print a few rows from the Titanic data set. So here we will put in comments print the first, we'll do 10 rows of the data. Okay, so to do that, I just type Titanic dot head, and then we'll put 10 there, and let's run this. Okay, and now we can see that we get back 10 rows of data, and we can see a few things since we are trying to analyze the data and get familiar with this data. One thing that you may notice is this P class column here and this class column here. They seem redundant. Wherever you see a 3 in P class, you will see third in class. And wherever you see a 1 in P class, you will see first in class. Okay, and wherever you see 2 in P class, you will see second in class. Okay, so these seem pretty redundant, and these are not the only columns that are like this. As you continue on looking at this data, if we scroll over, you'll notice for columns embarked and embarked town that they seem to correlate as well. So wherever you see S in embarked, you will find Southampton in embarked town. And wherever you see a C in embarked, you will find Cherbourg in Embarked Town. And then wherever you see a Q in Embarked, you will see Queenstown in Embarked Town. Okay, so again, like I said, those are still not all of the columns, but that's what I can immediately see when I first looked at this data set. So let's go ahead and continue here. Let's create a new cell. And then what we're going to do here is get a count of the number of rows and columns in the data set. So let me go ahead and bring this up. In the comments here, I'm going to put count the number of rows and columns in the data set. Okay, so to do this, you just type Titanic dot shape and run this. Okay, so what we see here is that we get 891 rows of data and 15 columns. And what we're really looking at is 891 passengers in this data set. So this tells me that this is a subset of all of the passengers on the Titanic, because there were more than 891 passengers. But in our data set, we only have 891 passengers. Okay. All right. So next, let's go ahead and create a new cell. And I want to get some statistics. And so what that means is I want to get, a count of the number of, I guess, the number of passengers per data point. And we can only get statistics on numerical columns. So the column like class, we can't get any statistical data on because they're not numerical values. But P class, on the other hand, is. So it does contain numerical values. So anyways, to do that, we just type Titanic dot describe. Okay, and I go ahead and run this. And now we get some statistics on the numerical columns in our data set. And if we look at age, the first thing that you'll notice is the count on age is 714. And so that's not 891 like we would expect, which is telling us that the age column is missing a few values. Okay. And then also for age, we can see that the mean age is 29.69. We can see that the minimum age is 0.42 years, and I should have said that this is in years as well. So the mean age is 29.69 years of age, and the minimum age in our data set is 0.42 years. So that's about 5 months. So that's a baby. They're not even one yet on the Titanic. And it looks like the maximum age is 80 years old. So somebody on that ship was 80 years old. Okay. And then also we can look at this fare column, and we can see that someone paid 512.3292, I believe this is British pounds, to get on board. And that seems to be the maximum amount that that this person or someone has, or maybe there's multiple people. It could be multiple or just one person paid this price to get on board. And then it looks like the minimum price was 0 British pounds. So that's pretty interesting. And then the mean price looks like it was 32 pounds, British pounds. All right. So let's go ahead and create a new cell. So I think that's pretty interesting, when we look at the data like that. So you can see, basically what your mean is. You can see what you can expect to pay. You can see what you might get lucky with. You can see what you might get unlucky with when it came to price on the Titanic. And it's very interesting to see this data just through, these statistics. Anyways, let's go ahead and get a count of the number of survivors on the Titanic. So to do that, just type Titanic, and then I want the survived column, and then dot value underscore counts. Okay, and then I just run this, and this tells us that 549 passengers on the Titanic did not survive, which is indicated by that value 0, and 342 passengers on the Titanic did survive, which is indicated by that number 1. All right. So again, this is very, very sad. As you can see, more people did not survive than the number of people that did survive. Okay. And they all were, on what was believed to be a unsinkable ship. Anyways, let's go ahead and create a new cell, and let's visualize this count. So I'm going to visualize the count of survivors. And to do that, I just type sns.countplot. And then inside of this count plot, I'm going to type Titanic, and then I want survived column. And I think that'll do it. So let's go ahead and run this. Okay, and now we can see visually the number of survivors and the number of people that did not survive on the Titanic within this data set. Okay. All right, so now that we got this count for our survivors, let's get a count for other columns like the who column, the sex column, the P class, the SIP-SP column, the parch column, and the embarked column. And to do that, I need to create a new cell. And I will explain what these columns mean and some of the values that they have inside of them as we go on here, because I've already looked at the data. I also have a article on this on the Titanic here that you guys can read. I'll be sure to put in the description link below. I will be sure to put a link in the description below, not in the description, link below, and you guys can read it yourself. And I also put the meaning of each column, but I will explain it here in the video as we go on as well. At least try my best to. So anyways, here we're going to visualize the count of survivors for the columns who. We're going to use the column sex, the column P class, the column SIP-SP, the column parch, and the column embarked. Okay, and so I said I would go through what each column means. So who has the values man or adult male, adult female, which really the values are, I believe the values are man, woman, and child specifically, but a man is an adult man or an adult male, and a woman is an adult female, and then of course a child is either a male or a female that's under the age of 18. And then we have sex, which of course is just male or female. So there's a slight difference there, right? Because now we're just looking at two different values, right? So before we're looking at 3 different values, and now we're looking at 2, male and female. And then we have P class here, which is the number corresponding to the class that the passenger is in. So 1 corresponds to first, 2 corresponds to second, and 3 corresponds to third. So it's the class that the passenger was in, first, second, or third class. SIP-SP stands for sibling or spouse, and it's the number of siblings or a spouse on the ship with you. Or I'm sorry, not with you specifically, but of course with the passenger. And then we have parch, which stands for parent or child, and it's the number of parents or children that are on the ship with the passenger. And then we have embarked, which of course just says where the person embarked from, or the passenger. All right. So hopefully that was a decent explanation of the values in these columns and what they mean. So I'm going to create a variable called calls, which will be short for columns, and it's going to be a list that contains the the column names. So I'm just going to take this here and I'm going to copy it using Control C, and I'm going to paste it here using Control V, and now we have our list of column names, and we're going to make plots for all of them. So on a graph here, I need to tell it the number of rows and the number of columns that I'm going to have. So the number of rows will be n underscore rows, and it will be equal to 2. And then the number of columns will be n underscore calls, and I'm going to set it equal to 2, or 3 actually. And the reason why is because we have a total of 6 columns. So 2 times 3 is 6. 2 rows and 3 columns, I'm able to make 6 charts. Okay, and now I'm going to create the subplot grid, and I need to create the figure sizes. So the figure size of each graph. Okay, so to do that, I'm going to use something called plt.subplots, and this method returns a figure and an access object. So I need to create some variables here. I'm going to create a variable called fig, F-I-G, which will be short for figure, and axis, AXS, will be short for axis. So AXS will be short for axis. And I set that equal to that method. And within this method, it's going to take in a few parameters. So we need to tell it the number of rows that we're going to have, which will be n underscore rows. And then we need to tell it the number of columns that we're going to have, which is n underscore columns. And then we need to tell it each figure size. So fig size is going to equal n underscore calls times 3.2 and n underscore rows times 3.2. Okay, and I think that looks good. All right, so now let's loop through each column. So we're gonna need two for loops. So for r in range 0 to the number of rows, I also want for c in range 0 to number of columns. I want to create an index, so I create a variable called I, which will be short for index, and I set it equal to r times n underscore calls plus c. So this way our I variable can be numbers 0 to 5, and again this is the index to go through the number of columns, right? Because our last column name is embarked, and it's at index 5, and our first column name is at index 0. So we're going to be using that I to kind of loop through each of the columns. All right, so I'm going to create a variable called ax, and I'm going to set it equal to that axis variable, AXS variable, and we're going to show where to position each subplot. So it will be RC. Okay, and this right here again allows us to show where to position each subplot. Okay, now we need to create our subplot. So to do that, it's going to be very similar to how we did it above here using the SNS count plot. And that's what we're going to do here. So we're going to say SNS dot count plot, and then we need to tell it the column that we want to use. So instead of us having something like survived here, we're going to use the columns that we have up here. And of course, one of the columns name is who. So I'm going to put who here, but now this right here would make every single plot the who chart. So I don't want that to happen. I want it to go for each of these. I want it to go through each of these columns. And to do that, I'm going to use that calls variable. So calls, and then I could put in 0. And again, that would just give me the who column. So that's a problem. If I put just 1 here, that would give me the sex column. So I need a way to loop through all of them. And luckily, we already created this variable called I, which is the index that we're going to be using to loop through. So it's going to be I is going to be a value 0 to 5. So instead of using a specific number value, I'm going to use the variable I so that we can loop through each column. Okay. And then Hugh is going to equal Titanic survived. All right. And then I need to tell it the axis. So that's going to be X. Okay. All right. So I think that looks good. Let's give each of these charts a title. So x dot set underscore title. I need to put a dot there. Set underscore title, and it's going to be the column's name. So calls at position I. And then let's give it a legend. So x dot legend, and we need to give the legend a title. So that will be survived. And then we need to tell it where to position this or where it's located. So we're going to use LOC and set it equal to the upper right corner. Okay. And then we're going to use something called a tight layout. So just type plt dot tight underscore layout. And let's run this and hopefully everything's okay. All right. Everything looks good. So now we have our subplots. So these are our charts. We have the who chart, the sex chart, the P class chart, the SIB-SP chart, part chart, and then embarked chart. Okay, so now we can kind of look at this data here visually to see, who survived and who didn't survive. So again, 0 means that they did not survive, 1 means that they did survive, and 0 is represented by the color blue, and 1 is represented by the color orange. And so this is just a count of the number of passengers that did and did not survive. So if we look here on the who chart, it looks like men were not likely to survive. The majority of the men in this data set did not survive. Over 400. I don't know what this exact number is, but it's over 400 men. And in total, in our data set, we had, I think it was 891 passengers in this data set. So obviously this is over 400, so that's a ridiculous amount. Over half of the passengers that did not survive were men. All right, so I hope I said that right. Next, we're gonna look at this sex chart, and we can see males seem to be likely to not survive in this chart as well. Over 400 males did not survive. Okay, and let's go to P class. And although the legend is over that third class here, if you look kind of behind it, you can kind of see the bar chart behind it, or the bar behind it, and it looks like if you were in third class, over 350 passengers in third class did not survive. So, if you were in third class, it looks like your chances of survival were not good. You're actually most likely to not survive if you were in the third class. Okay, let's go ahead and go down here. So for sib SP, again, that's sibling or a spouse that's on board with you or on board with the passenger. It looks like if that number was 0, you were not likely to survive. Almost, it looks like it's just under 400 passengers who did not come on board with a sibling or a spouse did not survive the Titanic. And then, of course, look at the parent-child chart, which tells, of course, if you came on board with a parent or a child, or I'm sorry, if you're there with a parent or a child, I'm not sure if it necessarily means that you came on board with them. So I don't want to, be incorrect there. But it looks like if you did not have a parent or a child with you on the Titanic, uh, it seems like you were more likely to not survive. So over 400 passengers who did not come with a parent or a child did not survive. And then embarked, it looks like if you had embarked in S, which S is, I think, is Southampton. So we go back up here, and I'm just going to scroll this on over. Yes, Southampton is S. Let me come down. It looks like you were not likely to survive as well. So just some interesting charts with this data. All right. So hopefully that wasn't too confusing. Let's continue doing some more analysis on this data. Let's create a new cell here. And this time, let's look at survival rate by sex. So to do that, just type Titanic dot group by, and we're going to group by sex. And then we want survived, and then dot mean. Okay, and then run this. And now what we can see is that 74.2% of females in this data set survived, while only 18.89% of the males within this data set on the Titanic survived. So that's a really, really, really low survival chance. All right. Let's look at survival rate by sex and class. So I'm going to create a new cell here. And in comments, let's say look at survival rate by sex and class. And so to do that, we just type Titanic dot pivot underscore table, and then we're going to look at survived. We're going to look at index equals sex, and columns equals class. Okay, so I'm going to run this. And so now we can see that 96.8, we see that females in first class have a 96.8 chance, 96.8% chance of survival. And so that's the highest survival rate out of all of the classes and the sexes. And then it looks like males in third class have a 13.54% rate of survival. So that's again pretty low. And if you happen to be on the Titanic, you probably would have wanted to be a female in first class because your chances of survival were the highest, while you would not want to be a male in third class because your chances of survival are the lowest. All right. So let's go ahead and create a new cell here. And I'm going to show you guys something that's kind of cool. We're going to look at survival rate by sex and class, but visually. And I'm going to show you how easy we can do that using this pivot table. So I'm just going to come up here and copy this using Control C and then paste it down here. Okay. And I will say look at survival rate by sex and class. We're going to put visually here. And look how easy this is. All you have to do is add on a dot plot, and you can plot this right away. So just run this, and now we can see basically what we saw up here, we can see in the graph here. So it looks like, again, we have females here to the left and males to the right. It looks like, again, the first class has the highest survival rate overall. And I'm not sure if I actually mentioned that before, but we can see that here as well. So you see first class for females has the highest survival rate, and first class for males have the highest survival rate. But now we can see that graphically. I did say that females have a 96.8% chance of survival, and we can see that right here. And I did say that the males have the lowest survival rate of 13.54%, which we can see here in the green for men in the third class. And so, of course, the green line corresponds to third class and the blue line corresponds to first class. So let me just say this again, that women, or that females in the first class had the 96.8% chance of survival, and we can see that here. Okay, and you can see basically everything else for the second class is right, right there in the middle. But all of these values show a higher survival rate than men. So women overall had a higher survival rate, and we can see that for each class. And then, of course, men had the lower survival rate for each class. And even the highest survival rate, which was males, and I say men, but I really mean male, the highest survival rate for males was in first class with 36.8% chance of survival, and that still was lower than the female's lowest class, which is a third class. It's still lower than their rate of survival for that class. So anyways, again, it looks like you don't want to be a male on the Titanic. All right, so I think maybe we'll do about maybe a few more, 3 more charts or so, maybe 4, to keep analyzing this data. Let's go ahead and create a new cell. I want to now plot the survival rate of each class. So to do that, I just type SNS dot bar plot, and then we need to give it a x-axis. So x-axis will equal class, and we give it a y-axis label. So y will equal survived. Okay. And so class and survived are 2 columns as well on our data set, right? So our x-axis is going to contain the class data, and our y-axis is going to contain the survived data. And we can tell it what data set to look at. So we want to look at the Titanic data set. And of course, it's going to give it the label survived in class as well. So let's go ahead and run this. Okay. And so we can now see a nice bar chart. And like we saw in this chart here with first class and then second class and the third class survival rates, now we can see them as bar charts. And what we see is what we observed before. We see that the first class has a survival rate of slightly above, looks like 60 something percent here. And then third class has a survival rate of slightly below 0.3 or slightly below 30% chance of survival. So yeah, you also want to be in first class as well, because your chances of survival are higher than any other class in general, whether you're a male or a female. Okay, so let's go ahead and create a new cell. And yeah, we're just analyzing the data. And I hope you guys are seeing, like a pattern here. It really looks like males, survival chances are horrible. And third class survival chances are horrible as well on the Titanic, which is really sad. Let's look at survival rate by sex, age, and class. So to do this, I kind of need to break up age a little bit. So age is going to be equal to PD dot cut, and we're going to cut the Titanic age. Titanic age. Okay. And I want to cut it into people who are older than 18 and people who are younger than 18. So 0, 18, 80. And I'm choosing 80 because that was the maximum age in our data set. All right, so hopefully, yeah, that should do it for age. Okay, and now let's go ahead and create our pivot table. So to do that, we just type Titanic dot pivot underscore table. And inside here, we want survived. And then we want sex and age, the variable, and then class. Okay, so now if I run this, hopefully we get this nice pivot table, and we do. So now we can see sex, and we can see age, and then we can see our classes here. All right, so it looks like if you were a woman, a female who was 18 or older, then your chances of survival if you were in first class is 97.29%. So that's pretty high. So if you're a female and if you're an adult female, your chances of survival are pretty good. They're the best compared to anyone else that we're looking at here. You know, let's see who's the worst. If I look at this data, it looks like this is the smallest number. And so this is a male who's 18 or older. So this is a grown man. And it looks like the survival rate for a grown man in second class is just 7.14%. So you were not likely to survive if you were a man, a grown man in the second class. So I'm still seeing the same pattern, no matter how we dice up the data sets. All right, so let's go ahead and create a new cell. And this time I'm kind of curious about the prices for each class, because if I was a female at this point, and if I happen to, I guess know that my chances of survival would be higher in first class, I may want to look at the price and see what's the cheapest price I can get for first class. But of course, they might not have known, that they had a higher chance of survival, or maybe they did. I'm really not sure. But anyways, let's plot the prices paid of each class. So to do this, I'm going to use a scatter chart or a scatter plot. And to do that, just type plt.scatter. Okay, and in here, I need to tell it the columns that I want to look at. So I want to look at the class and I want to look at the fare. So let's see, Titanic fare. So that will be my x-axis, and Titanic class. That will be my y-axis. And then each dot on the plot will have a color of purple. So they each will be purple dots. And then I'm going to give this a label. So label is going to equal passenger paid. So this tells me how much, or it tells me the price that the passenger paid to get in what class, what price were they paying. All right, so let me see, plt dot y label. So we're gonna give our y-axis a label and we'll call it class. And then plt dot x label. So we're gonna give our x-axis a label and I'm gonna call it price slash fare. And how about a title for our graph? So plt dot title, we'll say price of each class, and then we'll give it a legend as well. So plt dot legend, and then we want to show our plot. Okay, so let's run this. Excellent. So we can see each dot is a passenger, and our x-axis is the fare, and the y-axis is the class. And so we can see here that somebody paid over 500 British pounds for first class, and we saw that earlier above when we were looking at the max fare value. And it looks like, yeah, it looks like every class here somebody paid 0 British pounds. So that's interesting. And if I look here, it looks like, oh, it looks like anybody who paid 100 or more British pounds were all in first class. So it looks like if you paid more than 100 British pounds, you automatically get first class. So that's pretty interesting. I would, if I was trying to get on a ship, I would want to pay the least amount. So that 0 British pounds would have looked good to me if I were boarding the Titanic. But let me go ahead and create a new cell here. And I think we're good to go on the graphs. I think we've analyzed the data visually very well. So I think we have a good understanding of this data set. Now I want to check which columns contain empty values. So here we're going to count the empty values in each column. And to do that, I just type Titanic dot is in A, and then I want the sum of the missing values for each column. Okay, so let's run this. And like we had saw earlier, the age column is missing some values. It's missing 177 values. And embarked is missing 2 values, and embarked town is missing 2 values. And then deck is missing 688 values. So that's a lot of values to be missing. I think that's over 77.22-ish%, 77.22% of the data is missing for the deck column. So we're going to get rid of that deck column. We are probably going to get rid of the missing rows for age, embarked, and embarked town. And also I kind of want to get rid of some of the redundant columns. So let's look at all the values in each column and kind of get a count and a feel of the columns that are redundant. So I'm going to create a new cell, And again, we're going to look at all of the values in each column and get a count. So to do that, I'm going to use a for loop. So for val in Titanic, I want to print the Titanic val dot value counts. Okay, and then I'm going to print a new line so we can space it out a little bit. So I'm going to run this. Okay, and so what we can see is different counts for each column. So now we have survived. We've got this count earlier where, there's 549 passengers who did not survive and 342 who did. But now we also have a count for every other column. Okay. So the reason for this is so that I can look at these columns and I can look at the number and I can see, which columns basically have the same number and the same, I want to say values or similar values as well. Now, I wouldn't usually recommend you doing something like this, but we're just going to do this just for this video, just to kind of show you guys that there are redundant columns. Okay, so let's take a look at alive. So the alive column has 549 no and 342 yes. And so we can see that this corresponds to, if we go all the way up here, it corresponds to survived, which we looked at earlier. Instead of no, we have 0 for survived, and instead of yes, we have 1 for survived. Okay. So this tells me that that column alive is redundant. And I'm going to keep the survived column because it is a number. While here, the other column, if I go down here, alive is not a number. So despite this data type here, this D type, which this is not for the column itself, because the column has these values yes and no. Don't worry about the int64 portion. I'm sorry, actually I highlighted that in the first place, but this does not correspond to the data type of the column. But we will look at that as well. We will look at the data types. Okay, so let's look at another column. So if I look at class, we can see class has 49, 216, 184 for third, first, and second. And then if I look at P class, let's find P class. That's further up. Okay, P class here. All right, and P class for 3 we have 44. I said 49, 491. For 1 we have 216, and for 2 we have 184. And let me scroll back down here again. Make sure I did not mess up my numbers here. I meant to say, if I said 49, I meant 491 for third for class, 216 for first for class, and 184 for second for class. Okay, so I just wanted you all to kind of see this and get a feel for the different values before I drop them and remove them. So it's going to create a new cell, and here I'm going to drop the columns. So to do that, I just type Titanic dot drop, and then inside here I put a list of the columns of the column names that I want to drop. So deck, embark, embark town is the name of the column, and then alive, and then class, and who. I'm doing who because we have age and we have sex, so we don't need to know if the person was an adult an adult male or an adult female or a child. So I'm going to get rid of that column. And I think I need to get rid of alone and adult male. Adult underscore male. So I'm getting rid of alone because this tells whether the passenger is on board by themselves, meaning that they are not with a sibling or a spouse or a child or a parent. And we already have columns for that. And of course, we already have column sex and male to determine if somebody's a adult male. We have P class for class. We have survive for alive. And for embark town, we have embarked. And then deck is just is missing too many values, so we're getting rid of that. Okay, and so I need to tell it to get rid of these columns. So to do that, I put a comma here and then put axis equal to 1. All right, and then I want to remove the rows with missing values. So to do that, I just type Titanic dot drop in A and put in subset equal to, we need to tell it the rows for which column we want to drop that are in A, that are missing. So that's the columns embarked and the column age. Okay, now I'm not really done yet. This basically creates a new data set for us. So I need to update my current data set, which is named Titanic. So I need to set it equal to this new data set with these dropped columns. And I need to do the same thing for this new data set with these dropped rows. Okay. All right, so let's go ahead and run this now. Okay, I might have misspelled something. Subset. And I need to set that equal to that. And now let's run this. Oh, okay, so it went ahead and already dropped these columns here. So I'm just going to comment this out for the moment, and we're going to run this. Okay, and now we have our new data set, and I'm going to uncomment this. All right, so let's create a new cell here, and let's take a look at the new number of rows and columns. So here we're going to count the new number of rows and columns in the data set. And to do that again, we just type Titanic.shape. All right, and if I run this, we should have, I think, 712-ish rows and 8 columns. All right, so that looks good. Okay, wow. So all of this is just kind of getting the data ready now for our models. So let's go and create a new cell. And let's look at the data types like I said before. So look at the data types. So to do that, we just type Titanic.dtypes. And let's run this. Okay, and now we can actually see the data types for each column. And we can see that every column is a number value except for sex and embarked. So we need to change them to be number values. All right, so let's see how we're going to do this here. I'm thinking here. So we can use something called sklearn pre-processing to do this, and they have a method called label encoder, which transforms our object data types to integers. So let's actually do that. So I'm going to create a new cell here, and from sklearn dot preprocessing, we want to import label encoder, and I'm going to create a variable called label encoder and set it equal to the label encoder method or constructor. And now we can encode our columns. So let's encode the sex column. And to do that, I just type label encoder dot fit underscore transform, and I need to tell it which column I want to transform, and that's the Titanic dot iLock, all the rows from column at index, let's see, 0, 1, 2. So put 2 here because that's where sex is, and this needs to be a array. So dot values here, and I want to put this back into our data set. So I'm going to copy this and paste it here, and then set this equal to that transformation. And then I need to do basically the same thing for embarked, which is 0, 1, 2, 3, 4, 5, 6, 7. So it's located at index 7. So I'm just going to copy this. I'm going to copy this whole thing using Control C and then Control V to copy it. To paste it. And here I'm going to put embarked. Okay, and we want to change the values at position 7. So let's put 7 here. Okay, and that will actually transform my data. Before we do, let me create a new cell here and let me move it up, and let's print the unique values in the columns. So I want to show you guys the values in our new data set now, but I want to show you what the values that are not numbers look like. So our sex column and our embarked column values. So to do that, I just type Titanic and then sex and then dot unique. And then I'm going to copy this and do the same thing for the other column, which is called embarked. Okay, so let me run this just so we can see what the unique values are. So we have male and female in sex, and then we have S, C, and Q in embarked. And now I'm going to run this transformation here. So hopefully there are no errors. Okay, looks good. So I'm going to exit that there. And I'm going to copy this here using Control C again. And I'm going to create a new cell, and I'm going to paste it here. And now let's look at these values once they're transformed. And we can see that we get 1 for male. We get 0 for female. And then we get 2 for S, 0 for C, and then 1 for Q. So now our data is transformed into numerical values. So if we look at the data types again, so I'll create a new cell here, and we just type Titanic dot dtypes with an S, and I run this, then now we can see that all of the columns are numerical columns. Okay. All right, so we are almost there. I do apologize for the video taking so long, but let's create a new cell here, and we're going to split the data into independent, and I call it independent X, and dependent, I call it Y variables. Okay, so I'm creating a variable called X, and I'm going to set it equal to Titanic.iLock, and I want all of the rows from columns at index 1 to 7, and this is going to be an array. And so notice I started at 1 and not 0 because at column 0 is the survived column, and that's what we're going to use. Um, that's what we're going to use to make our prediction. I mean, that's what we want. That's our target, and we're going to use the X data set to make our prediction. So we're going to leave out survived. All right. And then also you may notice that I put a 8 here instead of a 7, because if I were to put the 7, then we actually be missing out on that last column called embarked, because that's at index 7. Okay. All right. And now let me go ahead and create my Y data set, which is the dependent data set. And I'm just going to copy this here and then paste it. And I don't want columns 1 to 7. I just want the column at position 0 or index 0. And so that's the survived column. That's our target. So again, we're going to be using this X data set to train our model to come up with the Y variable to tell us if the passenger survived or did not survive. And that's essentially what we're doing here, is just kind of splitting off our data. Okay. So let's run this. All right, and let's create a new cell. And now I'm going to create a function with many machine learning models. So to do that, just type def, and I'm going to call this function models, and it's going to take in an X training set and a Y training set. And you know what? We have not created our training sets yet. So let's go back up here. Let's create a new cell here. And we're going to have to split our data even more. So I'm going to create these training sets before we even start with this function here. So we're going to split the data set into 80% training and 20% testing. So to do that, I'm going to use the sklearn package again. So sklearn.model_selection. And I'm going to import train_test_split. And now I'm going to create my variables. I'm going to call them x_train and x_test and y_train and y_test, and set it equal to our method train test split. And I'm going to give it the data sets to split, so x and y, which we created just above here. And then I'm going to tell it the testing size. So the testing size is going to be 20% or 0.2. It's going to equal 0.2. And this, of course, automatically tells us that the training data set will be 80%. Okay, and then I'm going to give it a random state equal to 0. Okay, all right, so let me go ahead and run this. Excellent. We also have the option to scale our model, meaning that we make the data values and we put them in a range from like 0 to 100 or 0 to 1. And you know what? I'm going to go ahead and do it. It makes it easier and faster for our models to train on the data. So here we will scale the data. So to do that, from sklearn.preprocessing, I'm going to import standard scalar, and I'm going to create a variable called sc and set it equal to standard scalar. And I'm going to scale our X data set. So that is x_train. Well, let me think here. Do I want to scale it? if I scale my training data, then if I want to make a prediction in the future, I might have to scale my data. Anyways, it doesn't matter. Let's go ahead and scale it. So x underscore train, and we're going to set it equal to sc.fit underscore transform. Okay, and we're going to transform x underscore train, and then x underscore test. We're going to set that equal to sc.fit underscore transform, and then we're going to do x underscore test here. And let's run this. All right. Okay, so now let's continue with our function. So I'm going to put a colon here, and we're going to use logistic regression. So from sklearn dot linear underscore model, we're going to import logistic regression. And so I'm going to create a variable called log and set it equal to logistic regression. And we're going to give it a random state equal to 0. Okay, and then we need to train our model. So we just type log.fit, and we're going to insert our training data, which is x train and y train. Okay. We're also going to use some other models. So I'm going to use k nearest neighbors. So use k neighbors. So from sklearn dot neighbors, make sure I'm spelling that right. I'm going to import k neighbors classifier. And so I'm going to create a variable called knn and set it equal to k neighbors classifier. So I'm just going to copy this here and then paste it. Okay. And then I need to tell it the number of neighbors. So we're going to have 5 here. And you can mess around with these parameter values if you want to later on. And metric is going to equal Minkowski, I believe the name is. And then set p equal to 2. Okay. And then we need to train this. So knn dot fit. And I'm just going to copy this here because this is a lot of typing. And this video is actually taking longer than I thought it would. So next, let's use support vector classifiers. We're going to use the linear kernel. All right, so to do this, I'm going to use the library sklearn dot svm support vector machine, and we're going to import the support vector classifier. So I'm going to create a classifier called, or a variable called svc underscore len, and I'm going to set it equal to svc. The kernel is going to be a linear kernel, and then random state is going to equal 0. Okay, and I need to train this, so I'm going to copy this here, and I'm going to type svc underscore len and then paste it. Okay. All right, so I'll create another SVC model, but this time this will be the this will use the RBF kernel. And so I can really copy all of this here and then paste it, and then just change a few things, like here, change this to RBF, change this to RBF, and change this here to RBF. Okay. All right. Now let's use Gaussian or Gaussian naive Bayes NB. So from sklearn.naive underscore Bayes, we're going to import Gaussian NB. So Gauss is going to equal Gaussian NB. And then of course, I'm just going to copy this here. We're going to type Gauss dot fit. Okay, let's see how many more models do we want. Probably 2 more models. I'm going to create a decision tree classifier. Decision tree. So to do that, from sklearn.tree, I'm going to import random forest classifier. And so I'm just going to create a variable called tree. I said random, not random. We're going to do a decision tree here, so not random forest classifier. But we know we use that next as well. So here we want the decision tree classifier. Okay, so I'm creating a variable called tree, and I'm going to set it equal to decision tree classifier, and the criterion is going to equal entropy, and then the random state is going to equal 0. And now the tree needs to be trained, so tree.fit. And now I will use the random forest classifier. All right, so let me bring this on up. So from sklearn.ensemble, import random forest classifier, and I'm going to create a variable called forest and set it equal to random forest classifier, and then I need to tell it the number of estimators, and we'll give it 10. Again, you can play with all these parameters here if you want to. The criterion will be entropy, and the random state will be 0. Okay, and then forest dot fit x train y train. Okay, that's enough of those. Now we need to return the models. So I'm going to return log knn svc underscore len svc rbf Gauss tree and forest. So that's 1, 2, 3, 4, 5, 6, 7 models. Let me make sure I have that. 1, 2, 3, 4, 5, 6, 7. Yes. Okay, so that's all of them. So let's run this. Okay. And now let's create a new cell. You know what? I also want to do another thing in this function. I kind of want to see the training accuracy for each model. So let's print the training accuracy for each model. So to do that, I'm going to do print, and then I'm going to put the position, the index position of each model. So 0 will be log, 1 will be the nearest neighbors, 2 will be the support vector classifier with the linear kernel, and so on and so forth. So here we're going to put logistic regression training accuracy. And to get that accuracy, it's just going to be log.score on the X train and Y train data. And I'm going to do this about 6 more times. So I'm going to just copy this and paste this 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to change these numbers here. So 1, 2, 3, 4, 5, 6. Okay, excellent. And then this is not logistic regression, it's K neighbors. And this one's not logistic, it's support vector classifier. Get rid of regression there. And this right here will have a linear kernel. Let me just put linear. There you go. So SVC linear. This one right here will be SVC RBF. This here will be Gauss or Gaussian MB naive Bayes. And here will be the decision tree. And here will be the random forest. Okay. So now we just need to change these. So it's going to be KNN. This is going to be SVC underscore LIN. This here is going to be SVC underscore RBF. Here we got GAUSS, Gauss. This is going to be the tree. And then here's going to be the forest. Okay, so now let me run this again. Okay. All right. So that looks good now. So we can finally get and train all of the models. So to do that, just type model equals models X underscore train and then Y underscore train. So let's run this. Hopefully there are no errors, and there are. So of course there are. Cannot import name Gaussian MB. So let's go up here to our function. And what did I misspell? Did I Gaussian? Oh, see, AU and then AU. And okay, so let me run this now, and let me run this here. All right, so now everything looks good, and we can see our training accuracy scores for each model here. So it looks like the model that did the best is the model at position 5, the decision tree classifier. Is about 99.29% accurate on the training data. And then the random forest was 97.5% accurate on the training data. So it did the second best on the training data. Okay, so I'm going to go ahead and create a new cell here. And in this cell, I'm going to basically create a confusion matrix and show another way to get the accuracy score. But this time we want to get the accuracy score on the testing data. So here I put show the confusion matrix and accuracy for all of the models on the test data. All right, so let me go ahead and bring that up. So from sklearn.metrics, we're going to import confusion underscore matrix, and I'm going to need a for loop here. So for I in range, and I want to go the length of the model. So the length of the model I want to create a confusion matrix for each model. So I'm going to create a variable called CM, which will be short for confusion matrix. And I'm going to set it equal to confusion underscore matrix. And we're going to work on the Y test data set. And then I want the model's prediction at position I. So this is going to go through all the models. I want each model's prediction. So predict the X underscore test data. Okay. All right. And then I want to extract the true negative, the false positive, the false negative, and the true positive values. So to do that, I'm just going to take these variables, paste them here, and set them equal to confusion underscore matrix. Actually, I'm going to just paste this here. So I'm just extracting these values, and then I put dot ravel. And now that I think about it, I really should have just put cm there since we already have. Since it's the same thing, I should just put cm dot ravel. But oh well, let's continue here. I want to now print cm, and I want to print the model and the testing accuracy score. So let's print model, and then I want the model's position, right? So I know which model I'm using, and then put testing accuracy, and let's see, we set it equal to, so we want the testing accuracy, model testing accuracy. Then we could put this nice little bracket here. Yeah, so let me see, the model at position I testing accuracy is going to equal this. Okay. And then we want the format. So dot format position I, right? So that gives us the model at position I. And now I'm going to get the accuracy score. And so to calculate the accuracy score, I'm actually going to calculate up here. I don't want to write it all there. I'm just going to create a variable called score, maybe test score. And I'm going to set it equal to TP, the true positive, plus the TN, which is the true negative, all divided by the true positive plus the true negative plus the false negative plus the false positive. Okay, and then we're just going to put test underscore score here. Okay, and I think that'll do it. And then I want to create a new line after each model. So hopefully there's no errors here. Let's run this. Excellent. So this looks pretty good. It looks like the model that did the best, the one that has the best testing accuracy, is model 6 here, or model at position 6, and that is our random forest classifier. So that's our random forest classifier. All right, so this tells me that let's see, the second best is logistic regression. It's the model at position 0 on the testing data. So this tells me that I really want to use the model at position 6 because it did the best on the testing data and it did the second best on the training data. So that's pretty good. All right, so it's about 83% accurate on the testing data here. So let's create a new cell. All right, and I'm going to do something. I'm going to get the importance of the features. So here we'll just say get, I'll just put feature importance. And to do that, I'm going to create a variable called forest and set it equal to our model at position 6 because that's the random forest classifier. And I'm going to create a variable called importance. Actually, I'm going to call it importances and set it equal to pd.data frame. Okay, and inside this data frame, I want the feature. And let's see, the feature will be Titanic dot ilock. I want all the rows from column at position 1 to the column at position 7. I want those column names. Okay, so then let's see what else. So I have the feature importance. So importance. And for importance, put colon here. We want to get the forest dot feature underscore importances underscore, and I want to round this, so I'm just going to use np dot round. Okay, running out of space here, and I want to round to 3 places. All right. Okay. Whoa, that was a lot. Let me make sure that everything looks good here. I think it does. Okay, so let's go down to the next line. And we're going to update importances. So importances is going to equal importances. We're going to sort them. So it's going to equal importances dot sort values. And we're going to sort the importance. Okay. In ascending no, we're going to do it in descending. So ascending is going to equal false. And hopefully I'm not missing anything. And then I want to set the index. So I set underscore index. I want the index to be the feature. Okay, and then we're going to print this out. So we're going to print the importances, and hopefully nothing goes wrong. Excellent. So we now have our importances to rounded to 3 decimal places, and we have sorted them in descending order, so from the largest value to the smaller value, and we now have the index here being feature. Okay, so that's what we did, and we have all of our columns, so that's one. Well, we have all of our columns from index 1 to index 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so hopefully all of that made sense to you all. So we have importance here, we have feature here because our feature is the index, so that's why it's down here. We sorted the values not in ascending order, so in descending order, and that's how we got that chart. Okay. All right, so I know that was a lot, and I hope I didn't confuse you all. So let's create a new cell here, and we're going to visualize the importance. So to do that, I just type importances dot plot dot bar. So that's how easy it is. And now we have this nice bar plot. Okay. And you can see age, fair, and sex seem to be important features. So let's go ahead and create a new cell here. And I want to print the prediction of the random forest classifier model. So I'm going to create a variable called pred, which will be short for prediction, and I'm going to set it equal to model at position 6 dot predict. And it's going to predict on the x underscore test data, and then I want to print that prediction, and I want to print a space, and then I want to print the actual values. So print the actual values. So we're going to print y underscore test. All right, so let's go ahead and run this. Okay, so now we can actually visualize what it's doing for each passenger. So, you know, a 1 means that our model believes the passenger survived, and a 0 means that the model believes that the passenger did not survive. And so again, up top here is our prediction, and below here is the actual values. So some match up and some don't, which is why our model's only, was it 83% accurate on that testing data. And I make sure I'm doing the testing data here. Yes, so we're using testing data here. Okay, so that looks good. Let's create a new cell. And now I really want to make predictions on, I want to make predictions on me. So I want to know if I am likely to survive. So I'm going to create a variable called my underscore survival. And I'm going to set it equal to this list here. So we have to kind of go back and look at our data set, right? So we have the column age, fair, sex, B class, SIB, SP, parch, and embarked. And let me go back up even further here because we need a specific order. So I'm gonna copy this here using Control C. I believe I can copy it. And it's going to come down here. And I'm going to paste it for now, just so I can look at the columns. All right. So my P class would probably be the I want to say the third or second class, because I want to pay a fare of 0 British pounds. So yeah, you know, we saw in the data set that even first class, there seem to be some people who paid 0 British pounds, but more than likely, I would not be paying a lot of money for first class, as I don't even usually uh, pay first class for an airplane trip, right? I just find it unnecessary. So I would probably do the same thing for the ship. So I don't know, I'll be in second or third class. So here I'm just going to put 3. All right. And next is the sex. So I am a male. So let's put 1 here. Age, my age is over 18. So I will put 21, a number that's over 18. I probably would not have any siblings or a spouse with me. So I'll put 0. I probably won't have any parents or children with me, so I'm gonna put 0 for that. The fare price that I would like to pay is 0, and where I embarked from, not really sure. I'm actually probably gonna choose a place. Let's choose embarked. I'm gonna look up here which one had the best survival rate. Embarked. Okay, so it's actually, it's not the survival rate, it's actually the count. And I'm really not sure which one has the best rate. So I'm just going to go with the lower count, which is this Q here. And our Q value, we changed, let's see here. Okay, so Q became the value, 1. So I'm going to put 1 there. Let me scroll all the way down here. So I'm going to put 1 here. Okay, and now we can get rid of that. And I think what we're going to have to do, since I changed our X data set, since I scaled it, I think we're going to do the same thing with this, or with these values here. So yeah, let me go ahead and try that then, I guess. So this will be my survival, or this is my data based off of our data set right now. I'm going to use that feature scaling again. So from sklearn dot pre-processing, I'm going to import standard scalar. Okay, yeah, I don't think it really matters though. But anyways, we're gonna do it anyways. So sc equals standard scalar, and I'm gonna call this my underscore survival scaled, and set it equal to sc dot fit underscore transform, and we're going to transform my underscore survival. Okay. All right, so I think that looks good. Hopefully we don't have any mistakes there. Okay. All right, yeah, so I think that looks good. Okay, so let's do something else now. So here I'm gonna put my survival, and then here I'm gonna put scaling my survival, and here I'm gonna do print prediction of my survival using random forest classifier. So I'm gonna create pred again, a variable called pred again, and set it equal to model at position 6, which is the random forest classifier, dot predict, and it's gonna predict my survival scaled. Okay, and then I'm going to print the prediction. And also what I want to do is I want it to kind of say something. So if my prediction is 0, that means I did not survive. So I'm going to print, oh no, you didn't make it. Okay, and maybe I should put did not make it. And else, I'm going to print nice, you survived, exclamation point. Okay, so let's go ahead and run this. Okay, so invalid syntax else. Okay, that's because I forgot the colon here. So let's go ahead and run this again. All right, so it looks like the model predicted a value of 0, which means I would not have survived, and therefore it put, oh no, you did not make it. So it looks like I would not have made it on the Titanic. Now let's do something kind of cool. Let's see if we can change that value to 1. So let's see if we can do that by giving my survival data the best possible chance of survival. So we know that the P class with the highest rate of survival was class 1, was first class. We know that women had the best chance, so instead of 1 here, I'm going to put a 0 for women. I think children had the best chance. Let me look up here. So we're going to go all the way back up here to, well, I'm not sure about the rate, but the children had the lowest count. So maybe we want to be under 18. All right, so I'll put that. Actually, no. No, 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 no. If we go back up here, what we saw that females, we look at their age, right? Here we go. Um, Females had the best rate who were over the age of 18 of survival. So yes, I'm going to keep that 21. So my chances of survival are higher than females in the first class who are younger than 18. So I'm going to keep that 21. Okay. And then let's see, what's here? We have siblings. What's the maximum number of siblings? Let's go up here. And the maximum number of siblings, 8. And let's go, while we're up here, let's look at parent children, 6. So 8 and 6. So we know that they had a higher, well, it looks like, yeah. So for 8, oh, 8 did not survive. And same for 6. But more people who did not come with spouses or parents or children did not survive. So I'm not sure about this one. I'm still going to go with the higher number. So we'll go with 8 for SIB SP and 6 for parent children. So 8 and 6. Scroll back down here. So 8 and 6. Okay. And then the fair, if we're in first class, we probably paid a price that was higher than, to make sure that we're in first class, was higher than 100. So if I go and look at that scatter plot here, so yeah, because anyone who paid a fare below 100 seemed to be in third and second class, and we know that first class had a higher survival rate. So I'm just gonna put like 200 here. Okay, and then the town that had the yeah, I keep this town a 1 here, right? Because that was the, if we go back up here again, look at the towns embarked town. The queue here had a count of survivors less than the other two towns. So that doesn't necessarily mean that they had a higher rate of survival, because I did not calculate that. S may actually have a higher survival rate. Wait, no, 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 no. It looks like this C had more survivors than people who did not survive. So I think I'll go with that C. So what was C for embarked? Like we did a transformation on the data. So C is here and is 0. Okay, so we're going to go with 0 here. I think my chances of survival are pretty good now once I change this to 0. So let's go ahead and run this again. No, looks like I did not make it. Oh, that's sad. Maybe what if I change these values here to like 1? Would that change anything? Nope. Nah. I want to give it the highest chance of survival. So what if I change this to some high price like 300 or some higher price like 300? I'm still first class. I'm a female. What was the mean age? 20, 29? Let's do 29 here. Let's run this. Okay. And let's try a higher number here. So this model is just predicting no so far. I'm trying to give it the best possible chance. And again, first class seemed to be really good. Sex being female seems to be really good. Age being older than 18 seems to be really good. And maybe I will put 3 and 3 here. Let's try that. Nope. So it just looks like I'm not surviving at all. So this isn't really good. I'm trying my best though. Let's see if we can get it. Maybe if I change the town to 3. Nope. What if I change the town to 1? Nope. And let's try, instead of, we're gonna put back 300. Let's try 30 and run this. All right. So how about second class? Let's run that. Nope. So I think I gave it the highest, you know. Let's try 2 and 2 here. Okay. And let's try some really big number that's not in the data set, like 10. Let's run this. Nope. Okay. So I'm not sure if I can get it. Let's try 3. Nope. Okay, so far the model seems to only predict no. What if we get rid of this scaling here for the moment? And now let's run this. Okay, well, put the scaling back. I don't know what else to do for the likelihood of survival. Again, we're in first class. We're females. We are age. Let's try a younger age then. Let's try something like 10. And let's make this 8 and make this 6. Let's make this 0. Let's run this. Let's make this 200. Nope. Okay. Well, I tried. But anyways, this is our model. And this is the model that I would use to make my prediction, even though currently it seems to only give us no, which kind of makes me sad. I thought I'd be able to get a higher chance when I put in values like these here of surviving, but that doesn't seem to be the case with this model. So anyways, thank you all for watching this video. Please leave any questions you have in the comment section. I'm sorry it went so long. I guess that happens sometimes when you're analyzing the data. And don't forget to hit that like button and that subscribe button. And if you found this video helpful, maybe others will find it helpful as well. So please share it. And as always, thank you all for watching, and I'll see you all in the next video.